Yes. Yeah. Yes. Good evening, all. So myself, I'm Vijay. Like I hold 20 plus years of experience, which includes around 10 plus years of experience in big data, Hadoop and Spark environment. So before I start, can anyone please confirm whether my voice is clear, whether the screen is visible or not? Yes. So just as part of today's demo, I'll be discussing like what is Apache Spark. Yes. Fine. Thank you. Yes. So as part of today's demo, the top, what is Apache Spark? Why PySpark? Need for PySpark. Need for PySpark. Spark implementing, like if you've got Spark implementing with Python or with Scala, which one is the difference between this implementation with Python and Scala, right? And PySpark features, a real life usage. PySpark job market. PySpark job market, right? Yes. So this is what I'll be discussing, right? Starting with Apache Spark. What is Apache Spark? I define Spark in 5 lines. I defining Spark in 5 lines. Spark open source. It is an open source distributed cluster computing. In parallel processes type with in-memory computation with in-memory computation used for large scale data processing. In parallel process type with in-memory computation used for large scale data processing. Used for large scale data processing. It is an open source distributed cluster computing framework in parallel processor style with in-memory computation used for large-scale data processing, right? Yes. It is a general engine. It is a general engine, I can say. For big data analysis, processing, and computation. It is a general engine for big data analysis, processing, and computation, right? Yes. So you may ask, okay, distributed cluster computing framework. It is an open source. It's an open source, right? Distributed cluster computing framework. So Spark data is divided into smaller parts. It is distributed across multiple systems, processed and is processed parallelly by multiple systems. See, data is distributed across multiple systems and data is processed by multiple systems parallelly. And that too, Spark data is stored in the memory level, RAM level, not in the disk level. That's why we say in-memory computation. That's why we say there's in-memory computation within the RAM level storage and RAM level processing. That is what we call in-memory. And that too for large-scale data processing. So I can say it is a very high speed. It is a very high speed, very high speed processing execution model. It is a very high speed processing execution. For processing huge data, or big data, we say. It's a very high speed processing execution engine for processing huge data. And here, as I was asking, why PySpark? Why PySpark? Why we need to go for PySpark? Why PySpark? PySpark, right? Yes. PySpark is the Python API. It is the Python API to use Spark. PySpark is the Python API to use Spark. Just before I said it is an open source and cluster computing, which is used for big data solution. PySpark is the Python API to Spark. It is an open source cluster computing system, which is used for big data solution, right? Yes. PySpark is the one of the lightning fast. It is a lightning fast technology. It is the lightning fast technology that is designed for fast computation. It is the lightning fast technology that is designed for fast computation. It is one of the demanding tool. It is the very demanding tool among data engineers, right, to work with the bigger data set. Generally, PySpark used for what purpose? PySpark used for PySpark used for distributed SQL is used for distributed SQL, creating a data pipelines, creating data pipelines, ingesting data into a database, ingesting data into a database, running ML algorithms, distributed SQL, creating data pipelines, ingesting data into a database, running ML algorithms, working with the graphs, working with data streams. For distributed SQL, for data pipelines, ingesting data into a database, running ML algorithms, working with the graphs, working with data streams. A need for PySpark. Need for PySpark. See, you see, like a huge amount of data is getting generated. or through offline and through online. This data contains hidden patterns, unknown corrections, market trends, customer preferences, and other useful business information. It is necessary to extract valuable information from the raw data. So we require a more efficient tool to perform different types of operations on the big data. There are already various tools to perform multiple tasks. There are already various tools to perform. There are already various tools to perform this kind of tasks, but they are not so appealing. So we need a scalable and flexible tool to crack this big data and gaining some benefit from it. So PySpark is such a kind. So combination of Python and Spark would be the very efficient for the world of big data. That's why Apache Spark community came up with a tool called PySpark, that is Python API for Apache Spark. Python API for Apache Spark. Okay. You see, which one like Python implements scale Spark with Python or Spark with Scala? Which language to be used, right? See, Spark can be implemented in multiple languages, multi-language support. Mostly like Python and Scala are the mostly used languages for implementing Spark. But if you see the difference between Python and Scala, previously Scala was used a lot. You see in the year 2016, 17, 18, 19, Scala was mostly preferred. Now Python is mostly preferred in the industry because Python has got many libraries towards machine learning. Python is interpreted dynamic typed. So Python is interpreted dynamic typed. Dynamic typed means Python is dynamic type if you are assigning some value to it. So based upon what value you are assigning, based upon the value assigned, the variable x is created dynamically. If you are assigning integer value, integer variable created. If you are assigning a float variable to it, then x is what? A float variable created. If x equal to some string, a string value, x is a string variable created with depending upon what value you are assigning to that x, then that variable is created dynamically, right? Scala is statically typed. Python is interpreted dynamic type. Scala is statically typed. Yes. Python is slower than Scala. Python is slower than Scala. Python is slower than Scala, but it is an inter. See, Scala is faster than Python. Python is slower than Scala because it is interpreted language. Scala is faster. Frankly saying that Scala is faster. Because of Python interpretation, line by line execution, Python is slower as compared. But remaining all things, if you talk like Python has a huge community. Has a huge community. Scala community is smaller as compared to Python. Python supports 89,300 inbuilt modules it has got for different environment. Python has got supports 89,300 modules. Scala is used only for Spark. Python used for different environments. For different environments, different models are we have got, right? Python is providing for data science, for big data, for networking, for operating system, for databases, for networking. Python contains Python contains powerful libraries. It contains powerful libraries. Python contains powerful libraries. For data science, for graphs, streaming, etc. Python contains powerful libraries for data science, for graphs, streaming, etc. Scala has no such. So mainly like this. So these are the differences, right? Python is interpreted. Scala is statically typed. Python has huge community. Scala community is smaller. Python supports thousands of models. Scala is used only for Spark. Python contains powerful libraries. Scala has no such. PySpark features, main features, right? PySpark features. In-memory computation, in-memory computation, right? Yes. Storing and processing within the memory. Storing and processing within the memory, not like disk level, memory level. PySpark is lazy evaluated. Lazy evaluated. Lazy evaluated means active evolution. What is lazy evolution? Which one is better means lazy evolution, right? Active evolution, whenever defined, immediately. Whenever defined, immediately executing. Active evolution. Lazy evolution means on demand executing it immediately. Whenever defined, it won't execute. Whenever required, when you perform some action, then only it executes. Just like example, like in programming languages, functions, right? Functions won't execute automatically until you make some function call. They won't get executed. In same way here, data flows. Here we see data flows, right? The output of one will be input to the next one, right? So this data flows won't execute automatically until or unless you perform some kind of actions. Until then, they won't get executed. That is what lazy evaluated. Executing the data flow. Executing the data flow on demand when required. Next, partitioning. Partitioning, even this is also one of this, because Spark data divided into partitions. Spark data divided into partitions, and those partitions are distributed across multiple slave systems or multiple workers. Spark data divided into partitions, and those partitions are distributed across multiple slaves. This everything taken care by the Spark framework. You know, nothing to do, right? Automatically divides and it will distribute across multiple slaves. You don't need to perform anything. And Spark has a powerful fault tolerant model. Fault tolerant model. In memory computation, lazy evaluated, partitioning, fault tolerant. Fault tolerant. It has powerful fault tolerant, right? Powerful fault tolerance. Yes. Means whenever Spark data is divided into partitions and are distributed across multiple systems, any one system goes as their machines, any one system if they goes down, then there is some data loss and some task gets failed. So Spark has got the capability of regaining the lost partition. Spark has powerful fault tolerant model. Powerful fault tolerant model. See, it has got the capability of regaining the lost partitions. Immutability. Immutability. Spark data objects are immutable. Spark data objects are immutable. What do you mean by immutable? Mutable or immutable? Immutable means changes, modifications allowed. Immutable means changes, modifications not allowed. Spark data objects are immutable, means the original objects remains as it is. There is no modifications or changes. Next, persistence. Persistence. Reusing already executed, reusing already executed transformation. Reusing already executed transformation. Reusing already executed transformation. Already executed transformation instead of re-executing. Instead of re-executing, right? Yes. We don't need to re-execute again and again for multiple times. We can reuse it. Already execution transformation results. We can instead of re-executing, we'll be reusing it, right? Yes, so these are the main PySpark features, mainly in-memory computation, lazy evaluated, partitioning, Spark data is divided, partitioning, that is parallel processing, distributed, powerful fault tolerance, regaining the lost partitions, immutability, and persistence, right? Yes. Real life usage of PySpark. Hmm. It is used in the, I mean, some of those examples, commercial sector, in the commercial sector. See, Spark is for batch processing, not for online processing. Understand here? Spark is for batch processing, not for online processing. Whenever you give a request and not getting response, not that kind of architecture here. Not for request response. It is master slave architecture. It follows master slave architecture. So, okay. Batch processing. What is the difference? There are two types of applications. Online applications are there, batch applications. Online applications means user interactive applications. User interactive applications. User gives the input and user gives and gets the response. But but in case of batch applications, user is nowhere required. The user won't give any input. User non-interactive applications. Here, millions and trillions of records or transactions are involved, not like a single transactions. So commercial sector, some commercial sector like uses Apache Spark for real-time processing, banking, other financial fields. They're using Spark to retrieve customer social media profile and gaining useful insights, which helps to make the right decisions, credit risk assessments, targeted ads, customer segmentation, fraud detections, and widely used in machine learning tasks. And also in healthcare, even today in healthcare, Apache Spark is used in healthcare. Apache Spark is used to analyze the patient's records along with the previous medical reports to identify which patient is going to face that issue after being discharged from the clinic. Entertainment industry. It is one of the largest sector, entertainment industry, which is the largest sector, which is growing towards online streaming. The popular OTT platform like Netflix uses Apache Spark for real-time processing for personalized online movies or web series. It processes around 450 billion events per day that are streamed over server-side applications. Trade and e-commerce. Trade in e-commerce. The leading e-commerce websites like Flipkart, Amazon, all these they are using Apache Spark for advertising. The other websites such as even like Alibaba, like they provides enhanced customer experience, optimizes overall performance. So even in this e-commerce websites, like they are using Apache Spark for advertising, for recommendation, and even in the tourism industry. TV in the tourism industry, right? Yes. Apache Spark used to provide advices to millions of travelers by comparing hundreds of tourism websites. Right. So here, as part of this PySpark, PySpark SQL, PySpark Core. I'll be discussing about this PySpark Core programming, PySpark SQL, PySpark MLlib, PySpark Streaming. Yes. So as part of this course, you can just check with this course content, right? Yes. Before that, okay. 1 second. Just you can see in the chart also, right? Big message is given by this online team, the course content. You can just click on that. What I'll be discussing in brief, right? PySpark introduction. Why PySpark, need for PySpark, Python and Scala, PySpark features, real life usage, PySpark Spark session, context, parallelizing, repartitioning, broadcast variables, PySpark RTD computations, operations on a RTD, directed acyclic graph, RTD actions and transformations, RTD computations, steps in RTD computations, RTD persistence, various persistence options, memory only, memory underscore serialized only, disk underscore serialized, memory and disk only, right? Yes. PySpark core computation, fault tolerance model in Spark, different ways of creating RTDs, creating Spark objects from Scala and increasing the number of partitions, aggregations over structured groupings and aggregations, single grouping, multi-grouping, single aggregations, multiple aggregations, reduce by key, group by key, various inbuilt transformations and actions. Various actions and transformations, count by key, count by value, sort by key, zip union, inner joins, outer different types of joins, PySpark SQL data frame. So making data structured case classes using functions, data frame API, creating a data frame, empty data frame, the RTD to data frame, converting data frame to pandas. So structure type, structure field, row class, column class, select, collect with column renamed, where and filter, drop duplicates, order by sort, group by join, union and union all, union by name, UDF, map, flat map for each sample, partition by array type, map type, PySpark SQL functions, aggregate functions, window functions, data and timestamp functions, JSON functions, reading and writing JSON file, PySpark built-in functions. Various PySpark built-in functions when expr, lit, split, translate, overlay, to date format, date if, months between, arrays, collect, struct, map, rank, dense rank, PySpark external sources working with SQL statements, Spark and Hive integration, MySQL integration working with CSV, JSON, transformations and actions, narrow and wide transformations, adding of new rows, dropping of rows, new columns, handling nulls, writing data back to external sources, deployment modes, local mode, cluster modes, PySpark application states and tasks, building PySpark applications, PySpark streaming concepts, integration with Kafka and my PySpark MLlib machine learning library, right? So in brief, so here PySpark MLlib integration with Kafka, that is streaming data which keeps on generating, data which keeps on incrementing or generating, right? Streaming concepts and integration with Kafka, performance tuning mechanism, deployment modes. Okay. Offerings from my side. So you'll be getting each and every session video, right? You will be even if you're unable to attend a particular day, like it's a weekend batch, only on Saturdays and Sundays, Saturday for 2 hours, Sunday for 2 hours it will be. If any session, right, you will be getting each and every session video, even if you miss the session, right? Yes. Okay. Soft copy of the class notes, right? Soft copy of this class notes. Okay, what is it? Assignments and tasks to work. A WhatsApp group will be created for technical discussion. Interview questions. Interactive and hands-on. If you want to do the task, you can do parallel along with me. All the sessions will be interactive sessions. Total session during the sessions, right? You will be kept in unmuted status. At any point, you can unmute and you can ask the queries. And also you'll be responding for each and every task we do. You'll be responding, right? What is each statement does. Hands-on sessions, right? Yes. So clear soft copy of this notes, session video, assignments, tasks, WhatsApp group, interview questions, hands-on sessions, right? Yes. So yes, apart from that, right, even from DurgaSoft, as they mentioned, right, who people who gets enrolled, you'll be getting access to these videos. Around 120 videos access you'll be getting. You'll be getting Unix, Linux, and shell scripting 120 videos and MySQL videos. MySQL videos around 5,000 worth video access you'll be getting for this Unix shell scripting 120 and this around 35 videos for this. Yeah. So these are the offerings for my this. So tomorrow also people can attend the session same time at 4:30. Tomorrow we'll have some extra. So the session will be from 4:30 to 6. Today it was just an introductory session. What is PySpark and what is Spark? Why PySpark? Need for PySpark. Difference between Python and Scala. PySpark features. Real life usage of PySpark. And this offerings from my side. And even if you see this job market of PySpark. PySpark is one of the demand tool in the market. It has got very high demand. Even if you see the salary packages as compared with any other technologies, it will be 1.5 times more than other technologies. So you can see, you can just check in the Google also a lot of jobs for this PySpark jobs. So the salary package will be huge. In the same way, they'll be expecting some technicals from you. That means you need to have some command in this technology, right? So during this course, so it will go to the course will be like 8 to 10 weekends, right? The duration of this course 8 to 10 weekends it will be. Saturday 2 hours, Sunday 2 hours, 4 hours will be. Sometimes I'll be increasing. Okay. Any queries you got? Any you can unmute and you can ask your queries. Tomorrow follow the same link, same time at 4:30 to see more discussion on this PySpark. So just I'll be going with Spark data objects and computations to follow how data is, how the processing happens within this Spark computations and how this data is going to be distributed and how it is going to be processed parallelly, what happens internally, how this cluster processing within this Spark. Any queries you got, anyone, right? Fine. Fine. Okay. So tomorrow just will be carrying, so just where we have stopped, we'll be continuing from there. So tomorrow we'll have more discussion on this. So thank you all for your time. Thank you. Meet you tomorrow.